Okay, so now we'll move on to chapter 4 of the F3 book. We will start with the discussion of the integration lesson. Okay, so first we'll write down the standard integrals. So they have given you 11 standard integrals to start with. So the integration of sin x is cos x. So basically, integration is the reverse of differentiation. So basically, the cos x, sin x, we did a few differentiations in the previous chapter, right? So this is basically the reverse. Okay, so sin x integration is cos x, and don't forget the plus c, right? Integration constant, and the cos x integration is sin x. Tan x integration is ln cos x. So they've given you a set of rules here. Can you all see? So they have given you 11 rules. The first thing you should do is note down these rules. Okay, because we are gonna you are allowed to directly use these rules in any event of an integration. And you can see the star mark. So these particular rules are given in your formula book as well. Okay, so integration of sec square is tan x, integration of cos x square is minus cot x, integration of sec x tan x is minus sec x. So, so these rules, integration of cos x cot x is minus cos x. Can you see? So all these rules, I think these rules we did the other way in the differentiation lesson. I mean, when we came the other direction, integration of cos h was minus cos h cot. Yeah, sorry, differentiation. Differentiation of sec was minus sec x tan x. Isn't it? Differentiation of cot was minus cos h square. So this was what we did in the earlier lesson. Even these three rules we discussed in the other part, to the reverse side, right? In the differentiation lesson, differentiation of arc sin x is 1 over root 1 minus x square. So can you see that all the rules we did in differentiation, they've just written it to the other side. All the rules that we learned in differentiation, they've written it to the reverse side. So when you write it to the reverse side, that's called integration. Okay, so first thing they do is note down these rules, and then what we do is we are directly allowed to use these rules. You must be familiar with these results. You must be familiar with these results because you are allowed to use them directly, and you are allowed to do the sums. Okay, so first note them down. Okay, so in addition to these results, you can see if x is replaced by a linear function of x in results 1, 2, 4 to 7. 1, 2, 4, and 4 to 7, they can be generalized using f dash of ax plus b. So this is basically these rules that I've given you earlier. Okay, integration rules, I have not written them down. Okay, anyway, so this is the generalized one, right? Where if you have ax plus b, then you need to divide it with, you need to have a 1 over a times f of ax plus b. So basically, if you want to integrate sin instead of sin x, let's say we have sin ax plus b. So this is what we did in P3 as well, right? So in the case of sin ax plus b, what happens when you integrate? You get what? 1 over a cos ax plus b. Okay, so these rules also can be generalized by using the ax plus b rule. Are you with me? Okay, so you can generalize it by using the ax plus b rule. Okay, so then let's go with these rules and let's start these sums. Okay, so then yeah, and then two more things you need to remember from P3. The reverse product rule. You need to remember these two rules. Okay. So the integration of f dash x with fx to the power n is fx to the power n plus 1 over n plus 1. This is something you learn in P3 integration. Okay. And then the integration of f dash x over fx with respect to x is ln fx. So these are two rules that you learn in P3 and you need to be really familiar with them. We will be using them quite a lot in this integration chapter. Okay. Shall we start then? Okay, so we'll start with this and integrate with respect to x. We'll start with first one. So exercise 4A, question number 1, part A. So you need to integrate, they're asking you to integrate sin x plus 3 cos x. Okay, so how do we integrate? So I've taken the rules for you all to have a look. Okay, how do we integrate sin x? Sin x integration is directly cos x plus 3 times cos x integration is directly No, there's no minus in cosh. Okay. So you remember in the differentiation also, cosh differentiation was sign here. Cosh differentiation is sign. Sign differentiation is cosh. So if you are going reverse, also there's no negatives here. Okay. So plus 3 cosh integration is sin x. Just don't forget to put the plus. See, when you integrate, you must put the plus c. Part B, integration of 5 sec square x. Let's use the rules. Sec square x integration is given rule number 4. Can you see sec square x integration is tan x. Okay, then let's go to part D. Yeah, the 5 should be there. There should be 5 tan x, right? It's 5 sec square x, so 5 should be there. Sec square integration is tan. Okay. Then let's go to part B. Integration of cos x minus 1 over cos square x. So how does it work? These are all. So how does this work? Cos x, of course. No, yeah, we can direct integration cos x, but however, I prefer to integrate everyone together at the same time because I can see there's a 1 over cos square. So we need to fix this. How do we fix 1 over cos square? Cos square, 1 over cos square is sec square, right? 1 over cos square, sec square. So then you can integrate. So now we can integrate. We have the sec square integration rule in rule number 4, right? So then let's work on cos x integration is sin x minus mark is there. Sec square integration is tan x. And don't forget once again the plus c. Okay, so then let's move to part E. I'm just selecting a few questions randomly. Okay, I'm just selecting a few questions. Part E. In part E, integration of sin x over cos square x. Okay, how do we do it? Now, you know, integration rules are really strict. You need to follow this format. If it doesn't follow this format, can we integrate? No. So then what do we do here? How can I fix sin x over cos square x? How can I fix it? Yeah, we can write this is sin x over cos x into what? 1 over cos x, because then we have cos square. So sin x over cos x is tan x. So I still didn't integrate. You can see I'm just fixing it. 1 over cos x is sec x. Can you see I'm not done integrating. I'm just making it ready for integration because I need it to look like one of these 11 rules. You hear me? It needs to look like one of these 11 rules to integrate directly. So now it looks like sec x tan x is rule number 6. Can you see? So in rule number 6, integration of sec x tan x is minus sec x. So answer is minus sec x. Then we'll move on to part H. The integration of sec x plus cos h x into sec x plus cos h x is actually sec x plus cos h x square. Okay, so let's open the bracket. First thing is before you integrate, you must expand the bracket. Okay, let's expand the bracket. Okay, let's open the brackets. Let's open the bracket. Sec x into sec x is sec square x. Integration happens with respect to x. The next one, sec x into cos h is sec x cos h x, and again cos h into sec is again sec cos h. Basically, twice of sec x cos h x. Okay, and then plus cos h into cos h is cos h square x. Am I correct? Okay, so now let's go for the individual integration for each part. Okay, so I think according to these integration rules, we don't have the integration of sec cos h, and this cannot even be rearranged. So I think there is a small error in the sum. Okay, this one of them should be actually negative. Shall we fix it like that? Let's fix the sum. Okay, so that it can be, we can use difference of 2 squares here. Okay, so let's see what happens here now. Okay, so I fixed the sum. So let's open the bracket. Basically, now you have a minus b, a plus b. What is this? A minus b, a plus b is the difference of two squares. So basically, you get here sec square x minus cos h square x. Is that okay? Sec square x minus cos h square x. So integration of sec square x is given. Integration of sec square x is tan x. Minus integration of cos h square x is minus cot x. Can you see? It's minus cot x. And don't forget the plus c. So basically it's tan x plus cot x plus c. Okay. So now now I'll go to the next question. In the next question, what you need to do is you have to use the generalized format. So can you see in question number 2, they've given you sine 2x cos x over 3. So basically you need to use all these rules in their what format? In their generalized format. So basically if you have to integrate anyone in the form of f dash ax plus b. This could be sine ax plus b, cos ax plus b, tan ax plus b. Okay, whatever it is, it becomes what? When you integrate, it becomes 1 over a f of ax plus b, and don't forget the plus c. Okay, so all you need to do is you have to use this particular rule and follow these particular rules along with this. Okay, so let's try this one. Question number 2, part A. Integration of sine 2x with respect to x. Okay, what do we get here? So it's sine x. We have rule number 1, right? Can you see it's rule number 1? Okay, so integration of sine x is cos x. So however, I have sine 2x. So according to this rule, it's going to be 1 over a. The 2 is the a here, 2x. So it's going to be 1 over 2. Integration of sine is rule number 1. Cos should be, it should not be the x here. You get it? This should be ax plus b. So then basically ax plus b here is 2x. And don't forget the plus c. Okay. The b value is not there. Now in this case, because it's just sine 2x, the b is not there. You have like here, it's f dash 2x here. So then it's when you integrate also, you only get the 2x. Okay. Shall we try another one? Part B. Part C, just get used to this the format. Integration of cos x over 3. Use this rule, the generalized rule. So in the generalized rule, now you can see here your a value is what? What is a value in this case? A value is 1 over 3. Do you see? Your a value in this case is 1 over 3. Okay, so now remember when you are using the rule, the generalized, it has to be 1 over a, right? So 1 over 1 over 3. And then integration of cos is rule number 2. Integration of cos is sine x, but we don't put the x here because now we are using generalized. So f is sine, and it's x over 3. And don't forget the plus c. So 1 over 3 is 3. 3 sine x over 3 plus c. Okay. So the next one, part C also, get used to this. Integration of sec square 2x minus 1. So sec square is rule number, integration of sec square is rule number 4. Can everyone see? It's rule number 4. So according to rule number 4, and you have to combine it with the generalized rule. By the way, this generalized rule is only working for linear functions of x. Okay, you can't have x square here, x cube, or any other powers of x. The generalized rule is only working for the linear functions of x. Okay, so sec square 2x minus 1 gives you 1 over. So your a value is 2 here. Do you see? Your a value is 2 in this case. Okay, so 1 over a. 1 over a, sec integration is, sec square integration is tan 2x minus 1, and don't forget the plus c. Okay. when I say linear, I'm saying the inside part of the angle or whatever the inside the fx part is should be linear. But like you can have your h square and the x part is what I meant as linear. Okay. This so this is 2x minus 1. Now this cannot be an x square inside the function. Okay. Right. Then let's move to part D. Integration of cos h square 5x. So what is the a value here? In this case, your a value is 5. So it's going to be again 1 over a, which is 1 over 5 cos h square integration. Rule number 5. Minus into minus cot. Is it just x? No, they have 5x here. So you need to use 5x. Be careful, okay? Do not just directly use this rule and go wrong, okay? They've given 5x. You must use 5x here along with the 1 over 5. So basically the answer is minus 1 over 5 cot 5x plus c. Is that okay? Then we'll try a few more. Part F, part G, part F integration of such x over root 2 Okay, so which rule does this fall under? Sech x over root 2 tan x over root 2 is sech x tan x, which is rule number 6. Which is rule number 6. So this gives me the integration of this gives me, I'll write it down. So this gives me minus sech x, right? And then make sure it's generalized as well. What is the a value here? What is the a value here? Ax, so it's x over root 2. So what is the a value? What is the coefficient of x? It's going to be 1 over root 2. 1 over root 2. Okay, your a value will be 1 over root 2 in this case. So when we use the integration, it's 1 over a is again 1 over root 2 because 1 over a. 1 over a, sech x tan x, so the integration is sech tan is minus. So into minus sech, are we just writing x? Are we just writing x? No, we write the x is x over root 2. Okay, then this can be simplified. 1 divided by 1 over root 2 is going to give you directly root 2. Minus mark will come in front. Minus root 2. Sech x over root 2. Plus c. And don't forget the plus c. Okay, then we'll move on to part G, integration of 5 sine 5x minus 4 cos 4x plus 3 sech square x over 2 dx. Okay, so this is what you need to integrate. Okay, so how do we integrate this? Let's look at our rules. So according to the rules, the integration of sine 5x is directly available, right? Sine x is there, cos x is also there, sech square is also there. Everything is directly there. So all we do is to use the rule along with the generalization. Okay, so when you have here integration of 5 times, so there's a 5 outside. So let that 5 be there, right? When you integrate sine 5x, who is the a value? In this case, the a value is 5, which is 1 over 5. Sine integration is cos, and don't forget 5x minus 5x. I mean, it's just the 5x, and because it's 5x, I put 1 over 5 in front. Okay, so here minus 4 times cos 4x means what? The a value is 4. So basically 1 over a means 1 over 4. Cos integration is sine, and don't forget the 4x. It's not just x, it's 4x. Cos 4x, so it should be sin 4x. Next one, plus 3 into what is the a value here? A value is half. X over 2. So half x. So a value is half. 3 times 1 divided by half. It's because it's 1 over a. 3 into 1 over a. Sec square differentiation is tan x. So sec square x over 2 will be tan x over 2. And don't forget the plus c. So simplifying 5 to 5 cancels here. I get cos 5x. 4 to 4 cancels minus sin 4x. 3 into 1 over 2 is 3 into 1 divided by 1 over 2 is 6. And 6 over 2 plus c. So this is the answer for this integration. Okay, then let's move on to the next part. Okay, and then we'll go to the next question. Write down the results of the following. Okay, so third one, part A. So we are doing these questions so that you will be familiar with the integration process. Third one, part A, integration of 1 over 1 plus x square. Okay, so what happens when you integrate 1 over 1 plus x square? First, go through your rules. Do we have integration of 1 over 1 plus x square? Which rule number? Rule number 9. Integration of 1 over 1 plus x square is arc tan x. Can you see? So write the answer. Answer is arc tan x. And don't forget the plus c. Next one, part B. Integration of 1 over root 1 plus x square. So integration of 1 over root 1 plus x square is also there. Rule number what? Rule number 10. Can you see rule number 10? 1 over 1 plus x square. It's r sin x. It's r sin x plus c. Is that okay? Then we'll move on to part C. Integration of 1 over 1 plus x. Okay, which rule are we going to use? Integration of 1 over 1 plus x. Do we have it over here? No, then which rule? What rule are we using? Integration of 1 over 1 plus x. What's the rule that we need to use? We don't have 1 over 1 plus x here. Then what do? So then what we do is go back to the previous rules, the rules that you learned in P3 and P4 integration. So these are the general rules that you learned in P3, P4, right? Can you see? These are the general rules you learned in P3, P4. So you have 1 over 1 plus x. So which rule does it refer to here? Rule number 3. 1 over ax plus b integration is 1 over a ln ax plus b. Do you see? So it's basically it's just 1 plus 1 over 1 over 1 plus x. It's 1x. It's a 1x. So basically the integration is 1 over a is actually 1, right? Can you see? Because it's 1x. It's 1x. So 1 over 1 ln 1 plus x plus c. Okay, just go through the rules and do it. Next one. Integration of 2x over 1 plus x square dx. So again, when I look at this rule, do I have something like this rule in any of these 11 rules? The ones we learned in this lesson. I mean, we have 1 over. We don't have, especially, I mean, even the 2 is fine, but there's x on top. So we don't have any of these rules where you have x on top. So then let's go to the previous rules. So in the previous rules, which one do we need to work with? The rule number 10, f dash x over fx, where you have the differentiation of the denominator on the numerator. So denominator is 1 plus x square, denominator differentiation is 1 plus 1 is 0, x square differentiation is 2x. So we had it perfectly. F dash x over fx is there perfectly. So answer is ln of the denominator 1 plus x square and then plus c. Okay. And then part E. Part E, integration of 1 over root 1 minus x square. Integration of root 1 over root 1 minus x square. So which rule are we referring? Can we refer to a rule directly? Yes, rule number 8, right? It's arc sine. Rule number 8, 1 over root 1 minus x square is rule number 8. So this is directly arc sine x plus c. Okay, then rule number, let's go to part F. Part F, integration of 1 over root x square minus 1. 1 over root x square minus 1 is rule number 11, right? 1 over root x square minus 1 is rule number 11. The answer is R cos x. R cos x plus C. Then the next one, part F, part G. Integration of 3x over root x square minus 1. Okay. What about this one? Integration of 3x. Do we have any of these 11 rules with integration of 3x? No, right? I mean, there's no x in the numerator. So basically, I had to go back to one of these rules. So when I come back to these general rules in P3, P4, the first rules, of course, don't work. You can see that it doesn't work. There's no fraction here with the x on the top. So then obviously it has to go with either rule 10 or with rule 11. It has to go with rule 10 or 11. So how do we, which one do we use? Can I use the f dash x over fx, rule number 10? No, right? Because there's a root and I can't say with the root, the differentiation of the denominator is there in the numerator, right? No, I have to use which rule? I have to try to use the 11th rule. Okay, how does the 11th rule work? Integration of 3x root x square minus 1 is x square minus 1. I'll bring it up to the power what? Minus half. 3x times x square minus 1 to the power minus half. We bring it up. So then what we do is we can now see what is our, do we have the f dash x perfectly? So this is our fx. What is the perfect f dash x? I mean, you can ignore the power, right? The power n is this power minus half. Basically, I need the inside differentiation outside. So I have x square minus 1. Differentiation should be 2x. But you can see I have what? 3x. So can we fix it? Yes, let's bring the 3 out. And let's put a 2 inside. And to cancel off the 2, look what I'm doing here. Can you see what I did here? I removed the 3 outside. 3. Now remember, you can only remove a constant outside the integration sign. Can you remove x as you wish out of the integration sign? No, never. You can only remove the constant out 3, and then I put a 2 inside the integration and a 2 outside in such a way that they cancel out each other. So there's no difference to the sum. So now you can see I have the perfect f dash x to this fx. Can you see? The f dash x fx is there. So now I can use the rule. So when you integrate, you get fx to the power n plus 1 over n plus 1. The outside number 3 over 2 will remain the same. That doesn't change. Add 1 to the power x square minus 1 to the power minus half plus 1 is plus half. Divide by half plus c. So what do we get? 3 over 2 divide by half. The 2 to 2 cancels. We get 3 times x square minus 1 to the power half plus c. Okay. Then let's go to the next one. Part H, integration of 3 over 1 plus x square. So when you look 3 over 1 plus x bracket and whole thing square, do we have such a rule over here? Where you have 1 plus x and square of the bracket in the denominator? Definitely not, right? So then where do we have, what particular rule do we use to integrate this one? Can we even use this by rule number 3 in the general rules of integration we learned in P3? Can we use any of these rules? The third one, like, can we use if there's a power 2? No, right? So the only rule you can use is which one? Rule number 1. Now you might be wondering, rule number 1 has this in the numerator, but we have 1 plus x square in the denominator. So what do? Take it up. Take it up and fix it. So when you fix it, it's going to be 3 times 1 plus x to the power minus 2. And then we can now use rule number 1. So in rule number 1, it's the 3 is there as it is. The a value is 1 here, right? It's 1x. So into 1 over 1, ax plus b is 1 plus x to the power minus 2, you have to add 1, minus 2 plus 1, minus 1 divided by minus 2 plus 1. We could put minus 1 in one go. So answer will be 3 into 1 plus x to the power minus 1 over minus 1 plus c. Basically minus 3 times 1 plus x to the power minus 1 plus c. Okay, so then we have another set of just one set of questions to finish this exercise. We'll finish it off. Okay, so look at this one. Okay, so let's try question number 4 part A. Question number 4 part A. Okay, let's try this one. Okay, question number 4 part A. Question number 4 part A. Look, how do we integrate something like this? Integration of 2x plus 1 over root 1 minus x square. So you can see our numerator is quite large here, right? When you have an integration like this, what do you think is the ideal thing that we should do here? Now, we can't integrate something like this immediately, right? None of the rules. Now, I have a root 1 minus x square in the denominator in rule number 8, but that supports only when there's a 1 on top. Like, I can't have any x on top. So, what do we do here? Yeah, we need to split them. We have to split them from the numerator. So, how do we split them? Integration mark is there. So, 2x over root 1 minus x square plus 1 over root 1 minus x square. I need to split them. Okay. So now after splitting them, I think you can see 1 over root 1 minus x square is something we can integrate without any problem, right? Rule number 8. 1 over root 1 minus x square is rule number 8. However, 2x over root 1 minus x square is something that we need to work on. Okay, so we have to use which rule for this one? You know, none of these rules have x on top. So I had to go for general rules of integration and rule number. Can I use rule number 10? F dash x over fx when there's a root? No, it doesn't work when there's, we have to go with rule number 11 that I have mentioned here. F dash x fx to the power n. So this needs to be brought up and we need to fix our f dash x. Let's fix it. So 2x is there. Root 1 minus x square comes up as 1 minus x square to the power minus half. I'm not going to touch this other guy because there are, this guy we can integrate already, right? I'm not going to touch that person because that is something that we can already integrate. Okay, I'll separate the integration actually. Let me separate it. I'll put the integration sign here and integration sign here. Okay, then do we have the perfect f dash x? Now, this is your fx. What is the perfect f dash x? What's missing here? 1 minus x square, the power is n is minus half, right? So we don't need to be bothered with the power, but when you integrate differentiate 1 minus x square, the differentiation is minus 2x. You can see on top, on the front, I have what? Just 2x. So what is missing? A minus sign is missing. So to cancel the minus sign, I'll just put another minus 1 out here. Okay, so minus in and a minus out. It cancels out, right? Minus minus is plus. So now do you see I have the perfect f dash x fx? So these two terms are by the way separately there. Remember, I have taken this person separately and this separate. Two people are there separately. Okay. Then let's integrate. So there is a minus sign in front. Apply the 11th rule, fx to the power n plus 1, which is 1 minus x squared to the power n plus 1 is minus half plus 1 is plus half. Divide by n plus 1. Half. Plus 1 over root 1 minus x squared is rule number 8. Rule number 8 is arc sine x plus c. So 1 over half means it's basically minus 2 times 1 minus x squared to the power half plus arc sine x plus c. So can you see how this works?
Yes.
Yes, we'll do one more and we'll finish it off. Fourth one, part C. Fourth one, part C. Integration of x minus 3 divided by root 1 plus x square. I think You can see the rules are quite similar again, right? You have to what? Split. So x over root 1 minus x square minus, split the integral, minus 3 over root 1 plus x square. It's 1 plus, right? Here, sorry. 1 plus x square dx. So you can see again rule, the third one, 3 over 1 root 1 plus x square. Is it a problem now having 3 on top? Is it a problem? No. 3 is a constant. You could even take, you could take it out of the integration sign also. Like basically, I'll separate the two. I get here x over root 1 plus x square minus 3 times 1 over root, because I took the 3 out, because when I have it 1 over root 1 plus x square, I can use which rule? 1 over root 1 plus x square is rule number 10. 1 over root 1 plus x square is rule number 10. So I can go with this one with rule number 10. So this needs to be fixed. How do we fix this one? We need to use which rule? Rule number 11 here, right? In the general rules. So I bring the 1 root 1 plus x square up. Are you with me? So it becomes 1 plus x square to the power minus half. So what is missing? This is fx. The f dash x is? The f dash x is what? 1 plus x square differentiation is 2x, right? So I'm missing a 2.5. And then here minus this guy is of course okay. Nothing missing here, right? I'll integrate everyone together at once. Okay, so now this guy is ready to integrate, right? We have the perfect f dash x. Can you see we have the perfect f dash x with fx. So f dash x, fx to the power n, let's use half is outside, fx to the power n plus 1. N plus 1 is half plus 1 is half, divide by half. Minus 3 times 1 over root 1 plus x square was 1 over root 1 plus x square is r sin x, right? r sin x plus c. Okay. Yeah. So this is the discussion of the first exercise of yeah, half and half we could cancel. Yes. The half and half we could cancel, and yeah, we can simplify it a little bit further. We end up getting 1 plus x square to the power half minus 3 r sin x plus c. Okay, so this is the end of our first exercise in the integration chapter. Let's continue with the next exercise in the next video.